Now, section 1.3 talks about frequency tables. I'm going to completely skip this. We will come back to this idea very briefly when we hit chapter 3, but we're going to talk very little about um, these ideas, but it will kind of come back up with probability. So here's a definition for you. We're going to move on to our last section of this chapter, which is experimental design and ethics. We have two types of ways we can get data. The first is an observational study. It's a study that observes and measures specific characteristics without attempting to modify. We're just watching. We're not actually trying to see what's going on by adding in any treatments, by changing people's behaviors, by having them do something. We're just going to watch. Okay. And we're going to contrast that with an experiment. A design experiment is a study where we apply a treatment to some people, but we don't apply that treatment to other people. That's the control group. Control group meaning we don't apply treatment to them. And it helps account for confounding factors. What does that mean? There's a lot of words there that you may not be familiar with. An experiment is I have a group of people and I split them into two groups. Let's say these people have high blood pressure. I give half of them medicine that I think will help reduce their blood pressure. I give half of them a sugar pill. And then I can come back and see, did my group that got the drug medicine actually did actually help them medically or not? It can control for confounding factors. Confounding factors means things that would mess up my analysis, right? It can control for it because as long as my groups look about the same, then I can come back and say, yeah, the only difference in the group was the fact that one got a drug and one didn't. And so that means that the drug is probably the reason why one group performed better than the other. An observational study just watches people and doesn't actually change anything. So we're not adding a treatment, we're not adding a control group. You say, why would you ever do that? Well, in some cases you can't do a design experiment. If you think about things like smoking, you would never take two groups of people and say you have to start smoking and you have to stop smoking. That's something that we would not do as a country. So anything to do with alcohol use, tobacco use, things like that, we typically treat as observational studies where we just say, you do whatever you're going to do because that's something that we don't want to force on you. The downside, though, is we can only reveal trends at association. We don't reveal causation. So I'll come back at the very end of the course. But it's just a key idea to remember that when you're collecting data, if it's an experiment, I typically can say, I have a good feeling as to why these behaviors are different between the two groups. If it's an observational study, I'm just going to say this group tended to look this way and this group tended to have this happen, but I can't really say that there's a cause because there's other reasons that could be the cause because they naturally were the group that was smoking or not smoking to start with. So I don't know what the cause was necessarily. That doesn't mean it wasn't caused. It just means I can't conclude that. Okay, so those are the differences between an observational study and a design experiment. We have some problems with experiments. The first one here is the placebo effect. That's the one I'm having you write down. It's when subjects improve because they believe they are receiving treatment. And this is real. Not sure if you're aware of this, but in clinical drug trials, the placebo groups do improve in just about every area possible. I spent time working on a drug to help reduce migraine headaches, and our treatment group that got our drug performed very well, and they saw a significant reduction in migraine headaches. This drug is now on the market. It's, doesn't have a lot of side effects. Everything was great with it. But the interesting fact was that our group that got an injection, but an injection did not have the drug in it, also improved. Now, they didn't improve as much, and that's what happens. That's what we do in statistics. We say, did that control group do as well as the drug group? And in that case, they didn't, right? But the placebo group did improve. The subjects improved, and they didn't even know if they were getting treatment. No one knew if they were getting treatment, but the fact that they might have been, they actually had fewer headaches. It's crazy to look at this data, but the placebo effect is real. If you think you might be getting something, or if you think you might be doing something that helps you, your brain is super powerful. You have the Rosenthal effect, you have the Hawthorne effect. Again, just I think these are interesting ways we can affect experiments. Again, just for completeness there, just read through those just because I think it's neat, but it's not something you will be tested over. And then we're going to wrap this up with how do we correct that? We correct these issues mainly with blind and double-blind studies. Blind studies where the subjects do not know if they are receiving treatment or placebo. This is what I talked about with our migraine prevention drug. The people didn't know what they were getting, and that helps. If you tell someone you're getting a placebo, that effect goes away. If you tell someone they're getting a drug, that effect goes way up. If we'd have told the group of people who were getting the drug, they were getting the drug, then they would have done so much better than the people we said, yeah, we're giving you this, but it's not actually the drug, right? So we need our studies to be blinded. We need to not know if they're getting the treatment or placebo. But even better than a blind study is a double-blind study, which is a study where no one knows what's happening. The people getting the drug don't know what they're getting, but the people giving the drug don't also. And that's important because of that Rosenthal effect. If you go back to the previous slide, where the researcher can unintentionally influence the outcome, if the person giving the injection to our patients had known they were getting treatment, they might be really excited. These are people who work with these patients all the time, and they might have been like, yeah, I think you're going to do really well with this, right? And they would say, I can't tell you what you're getting, but they might have a better body, better body language, but some little more smile, a little more upbeat, right? And then the person that they were giving the placebo to been like, yeah, we're giving you this drug, but they would have known it wouldn't help them, right? So we don't want that to happen either. So you have to go through all sorts of weird technological things and labeling and code, uh, packages with codes on them, so no one really knows. So that way the person giving the drug to the patient, honestly doesn't know, and it's like, yeah, I don't know anything more than you, right? Maybe this helps you, maybe this doesn't, right? And that way we can get the best data possible. Why is this important? Again, we need good data because we're making an inference on a population. So we want to make sure that the data that we have is good. So again, our key takeaway is we need to make sure that we sample appropriately. And that way, when we get our data, we analyze our data, and we make an inference, we say, yes, this sample was representative. That means I can have faith in my results. If not, that doesn't mean we trash it. It just means we have to come back at the end of the problem and say, but my sampling wasn't very good. And that could be a problem because it's unquantifiable how bad it was. It's just something that I have to note, and I have to maybe use something else to help make my decision. Okay. So that'll wrap up chapter 1. Again, a lot of foundational definitions here, things that are kind of scattered a little bit, but all very foundational to the rest of the course. We're going to leave a lot of these ideas for a few chapters, but when we come back and build all this together, when we take what we learned in chapter 2, chapter 3, chapter 4, 5, 6, I believe, and then it'll be 7, we'll start really putting it all together into one thing. So it'll feel kind of disjointed as we go chapter to chapter, but as we start putting it all together, we're going to need to make sure that we feel good about all the things that we've learned in those individual chapters to put all the pieces together.